That was 1 second perfectly. Yeah, exactly one. .9.
That was .8.
Because air resistance can be neglected, the tennis ball's horizontal velocity remains constant. So we will use the equation delta x equals Vx times delta t. And because there is no initial vertical velocity, since we are hitting the racket at a 90-degree angle, we will use the equation delta y equals 1/2 ay times delta t squared. Now we will isolate delta t and set it equal to the square root of 2 times delta y divided by ay. Now we will go back to the first equation and isolate Vx to set it equal to delta x divided by delta t, which will substitute the square root of ay divided by 2 times delta y, all times delta x. We'll plug in the numbers and solve for Vx, which is the square root of negative 9.8 meters per second squared, which is the acceleration due to gravity in the y direction, divided by 2 times Colton's height, which happens to be negative 2.819 meters, times the displacement, the distance from serving the ball and the corner of the service box, which is 18.745 meters, which equals to 24.714 meters per second. Now we will take that and convert it to miles per hour to have a better understanding of what this means. And so it's 1 meters per second is roughly 2.237 miles per hour. So you take the meters per second and multiply it by the ratio, 2.237, which equals to 55.285 miles per hour, which is the fastest that Colton can hit the ball at a 90-degree angle while still staying in the service box. Now we will do the same process for my height, since I'm a bit shorter and have a smaller reach. So we'll take the second to last equation and substitute the numbers in. We'll keep ay, which is the acceleration due to gravity, negative 9.8, divided by 2 times my height, negative 2.413 meters, times the same distance, which equals to 26.712 meters per second. We'll convert that into miles per hour, which is about 59.755 miles per hour.